Now let's look at the main portion of the code of this producer-consumer implementation. We'll be creating two threads, thread ID 1 and thread ID 2. The first thread will be created to execute the producer function, and then the second thread will be created to execute the consumer function. We're using the default behavior for these, so we will have to join them later in the main function, in the main thread. And we will look at the producer and consumer functions next, but they don't take any input, so we're passing null as arguments. Note how we're checking for the return code of the pthread create operation in order to help with debugging. So the thread, the main thread, the one that's executing main, will just create the producer and consumer threads, and then it will do nothing. It will wait for them to exit. The producer function, so the producer thread, will try to execute for 20 times a loop in which it tries to produce an element for the shared buffer. During each pass through this loop, the producer thread will be trying to modify the shared buffer to add an element in that buffer, and then also to change the values of the shared variables like add and num. Therefore, all of this has to happen within a mutex lock, mutex unlock operation. We first do some error checking to make sure that we don't have buffer overflow. Now we're trying to produce data for the shared buffer. If the number of elements that are currently in the buffer is equal to the buffer size, that means that the buffer is full. So we have to wait. We have to wait on the condition variable that's associated with the producers. And this wait operation, we have to use the mutex as part of it. Remember, this mutex has to be used as an argument of the wait call so that the pthreads library knows which particular mutex needs to be freed and then reacquired after we complete the wait. Now, when we ultimately come out of the wait, so when the producer indeed comes out of the wait operation because the buffer is no longer full, so a consumer must have consumed some of the items in this buffer, then what do we do? Then the producer adds an element in the buffer. So it copies the value of I, this index I, copies the value of I into the element of the buffer that is indexed by the value of add, and then increments both the add variable as well as the num, the total number of elements in the shared buffer. Note, we may have a wraparound situation. So given that the buffer is a fixed size, buffer size, this add we need to wrap around in case it becomes greater than buffer size. Once we perform this, then we're done. We've inserted an element. We've updated the variables in such a way that it reflects that now there is a new element in the buffer. And so we can unlock the mutex. Now, the one thing that we didn't do is we didn't do any kind of signaling or broadcasting while we were performing this. It is possible that the buffer was empty when we perform this insert operation. And because of that, currently there is some consumer thread that's waiting on a condition. We've inserted just one element, therefore only one consumer thread can proceed. So what we'll do is we will notify a thread that's waiting on the condition variable, and we will use for this the signal operation, pthread condition signal, because again, we inserted one element, no point waking up 7 consumer threads. For sanity, I've inserted here some printout statements that will help you keep track of what's going on. These are not critical to the behavior of the multi-threaded program.